Hi, welcome back. Assalamualaikum. Today, I would like to continue our lesson on part 2, subtopic 7.1, determining rate of reaction. So, in this part 2, the learning outcomes or the learning standard that you should able to gain is to determine the average rate of reaction and instantaneous rate of reaction. And number 2 is to solve numerical problems based on the average and instantaneous rate of reaction. Alright, so first of all, let's look at the analogy below to give you an idea what is average rate of reaction and also instantaneous rate of reaction. Okay, we have two situations here. The first one, a car intends to travel for 400 km. Due to the ever-changing traffic conditions, the driver is not able to maintain a constant speed and took 4 hours to reach the destination. The average speed of the car is 100 km per hour. So this is equated as the average rate of reaction. So macam tu lah average rate of reaction ni kita tengok based on the total, keseluruhan dia. Total distance travel is 400 km and then divided with the total time taken is 4 hours. So dapatlah calculate dia punya speed ataupun dia punya rate of reaction. Which is 100 km per hour. Okay, so itu adalah average rate of reaction. Alright, for the second situation here, a police officer aims the speed camera in the direction of the car because it is travelling at a speed above the speed limit. At that instant, the camera recorded a speed of 140 km per hour. So the speed at that moment is equated to the instantaneous rate. So instantaneous rate, actually it is referring to the rate of reaction at a particular point of time. Okay, jadi dia nak at a given time, dia nak pada masa ini. Let's say dia travel tu dari pukul 8 pagi sampai pukul 12 tengah hari. So dia nak pada pukul 9:30 pagi tu berapa speed of the car. Ini cara dia, kita mesti buat gradient and tangent of a graph. Okay, so yang ni dia shoot je speed limit tu, dia dapatlah pada masa tu dia dapat 100 km per hour. So itu adalah instantaneous rate. Instantaneous rate, ingat dia mesti referring to the particular point of time. Okay, while average rate adalah total, keseluruhan. Okay, next one. Calculating rate of reaction. Actually, to calculate rate of reaction, kita kena faham there are two types of graph here. One is graph of quantity of a reactant change with time. So it will decreases as the time goes by because the reactant already used up. Lama-lama reaction complete dan habis. Itu untuk reactant. While for the graph of quantity of product, it will increases as the product form when the time increases, and then it will start to constant when the reaction is complete. So ini adalah graph for quantity of product. Okay, masuk ke types of rate of reaction. As we mentioned just now, it has two types of rate of reaction. One is average rate of reaction and the other one is instantaneous rate of reaction. So let's look at one by one. What is average rate of reaction? We have three more types in average rate of reaction. One is overall average rate of reaction, which is the formula used is the total quantity change, whether you want to use the decreases in the mass of the reactant divide with the time taken, or the increases in the product's form. Salah kalau products dia adalah volume of gas ke, ataupun the product's form adalah precipitate form ke. So kita ambil the quantity change then over with time taken. Okay, ini adalah contoh with the graph of volume of gas against time. So graph tu akan increases and then the reaction will stops here. So akan ambil masa ni lah untuk divide with the total time taken. Okay, ini adalah total volume of gas produced. So this is the total time taken. Okay, pada masa reaction betul-betul stop, masa itulah kita akan ambil total time taken dia. Okay, untuk second is the average rate of reaction for the first T1 second. For the first T1 second, maksudnya starting from initial, from 0, and then the volume of gas will increases until T1. So inilah dia nak average rate of reaction for the first T1 second. So what is the formula used? Kita ambil total volume of gas collected in the first T1 second. So this is the V1, volume of gas collected pada masa T1 ini. Dan masa pun ambil pada masa T1 lah, sebab dia nak until T1 second. Ataupun kita boleh minuskan dengan starting ataupun initial dia 0. So V1 minus with 0 for the volume dan divided with time taken to T1 minus with 0 also. Okay. Untuk keseluruhan T1 second. Okay, for the third one is the average rate of reaction from T1 to T2. Maksudnya kita nak for the specific period of time, tapi still lagi average rate of reaction. So contoh, this is the T1 and then this is the T2. So kita nak calculate this average rate of reaction. Maka formula used is the total quantity, let's say volume again produced. So V1 sini and V2 here. Okay, for T2 kita akan ambil bacaan untuk V2 minus with V1. Kita nak ambil dia punya differences for the volume produced here. And then untuk masa pula kita akan divide with time. Kita akan ambil differences between T2 and T1. Sebab kita nak tahu masa ini sahaja, pada masa ini sahaja time taken dia. Alright. So, yang kedua is the instantaneous rate of reaction. Instantaneous is referring to the rate of reaction that occurs at a specific time. So, apa formula used is the gradient of tangent at time t. So, you have to draw tangent and calculate the gradient. Okay, this is the steps how to determine the instantaneous rate at time t. The first one, you have to draw a straight line AB. Okay, straight line AB that only touch the curve at one point at t second. Okay, tengok contoh. Kat sini we have graph quantity of reactant against time, dan kat sini kita ada graph quantity of product against time. So saya ambil contoh yang ni Okay, let's say kita nak calculate the instantaneous rate of reaction at time t. So this is the time taken here. Ambil je time ni, kita extrapolate until it touch the curve of the graph. And then, pada point ini, kita akan drawkan a straight line of AB. Okay, A, B, dan this straight line touch the point at T second. Okay, so that's the first step. Okay, second step, draw a right angle triangle ABC. Maka daripada straight line AB ini, kita akan sambungkan, make it a triangle A, B, and C. Okay, 90 degrees triangle. In step 3, determine the length of AC and BC of triangle ABC. So, macam mana kita nak determine the length of AC and BC? So, kita gunakan kaedah determine the coordinate for B and determine the coordinate for A. So, let's say ini adalah X1 and Y1, while this coordinate for A is X2 and Y2. Jadi, kalau kita nak tahu dia punya length, Y2 minus with Y1, while X2 minus with X1, kan? Okay. Lastly, the rate of reaction is the gradient of tangent. Maka nak kira tangent, nak kira gradient dia, divide lah the length of AC tadi, Y2 minus with Y1 tadi, divide with the length of BC. Length of BC is X2 minus with X1. Divide dulu tu. Kita dapatlah dia punya gradient of tangent. Okay, so ini adalah example untuk calculation average rate of reaction. So saya bagi awak buat dulu untuk tengok macam mana, dan saya akan bagi jawapan dia. Okay, dah dapat? Alright, first kali kita tengok soalan. Reaction between calcium carbonate and hydrochloric acid release. This is information for volume of carbon dioxide gas. Okay, and then time taken is 100 seconds. What is the formula to calculate the average rate of reaction? Yes, it is the volume of carbon dioxide gas release. Ingat quantity of the reactant change ataupun quantity of the product. So sama ada lah. Dalam soalan ni dia dah bagi information for carbon dioxide, so kita guna quantity of the product form. Divide with time taken. Time taken adalah 100, maka 40 divide with 100 dapatlah 0.4. Unit mesti betul, cm3 per second. Okay, dapat Okay, next one. Example 2, we have 1.2 gram zinc powder takes 5 minutes to dissolve completely in excess hydrochloric acid. Calculate the rate of reaction in units of, one is gram per minute and the other one is gram per second. Ini pun information given for 1.2 gram of zinc powder. Then this zinc powder is a reactant which is dissolved in excess hydrochloric acid. Masih lagi reactant. Jadi kita nak guna formula of quantity of the reactant lah. Divide with time taken. Okay. So the fraction, ambil je mass of the zinc in unit gram sebab soalan dah bagi unit gram, and then divide with time taken. Soalan dah bagi dalam minute. So ambil je terus 1.2 divide with 5 minute. Akan dapat 0.24 gram per minute. Okay, while for B, this one you have to convert from minute to second. As 1 minute equals to 60 seconds, so times je 5 minutes ni convert pergi ke second, darab dengan 60. Yang lain sama, so 1.2 divide lah with 300 second. Dapat 0.004 gram per second. Okay. Okay, this is example 3, masih lagi dalam calculation average rate of reaction. Cuma kat sini kita akan gunakan ketiga-tiga formula yang given just now. The overall, the average rate of reaction in the first 2 minutes, and from T1 to T2. This one also, third minute also from T1 to T2. Sama, formula yang sama. Okay, so jom buat sama-sama. Overall average rate of reaction ni kita akan ambil the total products formed over total time taken. So maksudnya kalau tengok total of carbon dioxide produced ni daripada 0 increases until pada masa 210 second ni dia dah constant, dia dah stop to produce 34.5 dan 34.5 juga. Okay, maksudnya total of the carbon dioxide produced is 34.5 cm3. Tapi masa kita nak ambil yang mana? Masa we have 210 second and 240 second. So kita akan ambil yang the first yang dia starts to stop produce. Masa tu sebab dia dah complete dah reaction. Jadi kita kena divide with 210 second. So itu adalah calculation untuk average rate of reaction. Okay. Ini jawapan dia 0.1643 cm3 per second. Okay, for number 2, average rate of reaction in the first 2 minutes. Ingat, in the first 2 minutes, untuk keseluruhan 2 minit itu kita akan comparekan dengan initial dia yang 0 tadi. Di first 2 minutes, 2 minutes is 120 second. Kita tengoklah dia punya volume at 2 minutes adalah 26.90. So kalau nak tolak pun boleh, tak nak tolak pun boleh lah. Dia minus dengan initialnya adalah 0. Then time taken also from 120 second minus lah dengan time 0 yang initial tadi, sebab tu nak keseluruhan daripada 0 sampailah ke minute 2. Okay, kita dapatlah the answer is 0.2242 cm3 per second. Okay, soalan ketiga, the average rate of reaction from 90 second to 180 second. So this is the formula that you have to use from T1 to T2 dalam average rate of reaction. Jadi, let's say ini T1 dia dan ini T2 dia. Jadi, formula dia, kita kena tengok volume at T2 which is 33 and volume at T1 dia adalah 22. Minus lah dua ni. Then, time taken pula from T2 180 minus with T1 dia adalah 90. Okay, so kita akan dapat 0.1222 cm3 per second. Okay, final answer. If possible, bagilah for decimal place. Tapi kalau bagi 2 decimal place pun dah mencukupi. Okay, last one. The average rate of reaction in the third minute. In the third minute maksudnya dia nak dalam masa ketiga sahaja. Masa ketiga maksudnya third minute equals to 180 second. Dalam masa ni saja. Maksudnya kalau kita refer pada graph tadi, mana graph tadi? Okay, this one. Dia nak dalam tempoh ini sahaja. Maksudnya still you have to minus dengan minit sebelumnya sebab kita nak dalam tempoh itu sahaja. Okay, kat sini balik. So in the third minute kita akan ambil volume of carbon dioxide gas produced in the third minute. You have to minus with the volume of carbon dioxide gas produced in the second minute, minit sebelumnya. Okay, masa pun 180 second, minit ketiga, minus with masa pada minit kedua 120 second. Faham? Okay, average rate of reaction from minute 2 to minute 3. So kita akan ambil beza between minute 2 and minute 3 minus dengan minit yang sebelumnya. So the answer will be 0.1017 cm3 per second. Alright, so I hope you can try to solve activity 7.3 because time constraint. This one you have to do it on your own. Buat dulu, plot a graph dulu. Okay, this graph is referring to the reaction of manganese peroxide and hydrogen peroxide. So this reaction will produce water and oxygen. So this is referring to the oxygen gas produced. Jadi plot dulu graph. Volume of gas will be your y-axis. So this is your y-axis against time. So time will be your x-axis. Okay, plot dulu. There are altogether ada 15 points here. So make sure awak dah plotkan 15 points. Plot on your graph paper. And buat calculation untuk average ni macam biasa for the first minute, for the fifth minute, and for the whole reaction, average, total average rate of reaction. Dan barulah ada calculation untuk instantaneous. Ambil pada masa 1.5 minit, extrapolatekan naik ke atas. Dan barulah kita akan buat straight line, AB, make it a triangle, 90 degrees triangle, and then ambil coordinate dan kira dia punya gradient. Same goes to rate of reaction at 4.0. Buatlah straight line AB tu, buat triangle juga, and then calculate dia punya gradient of the tangent. So untuk soalan ni, you may refer to your textbook page 227 on solving numerical problems based on rate of reaction. So kat situ dia dah bagi contoh, dah bagi how to plot a graph, how to make a straight line and calculate the gradient of the tangent. Okay, so yang ni saya minta awak hantar personally ataupun WhatsApp boleh, Telegram saya boleh, sebagai homework hari ni. Dan as for your weekend work, I want you to complete test yourself 7.1 in textbook page 229. So this one, please upload the answer in Google Classroom. Thank you. Have a nice day. That's all.